All right, so we'll get going. Um, so last command we learned was unique, right? It will help you sort out the unique lines which are repeating right next to each other, okay? So the next thing we're gonna learn is date. If you just type date and hit enter, it will give you the date stamp. Okay, so it is showing today's date, December 21st. Um, uh, this is the timestamp and it says it's Eastern. Okay, so by default, the red hat is set to Eastern. Um, you could, when you're installing it for the first time, you could change that also. And if you type CAL, it will throw you the little calendar for the month. Okay, and if you do cal, if you want to see a specific calendar in future or in past, like you type cal, let's do December 12, 1969, and it's bringing you up the calendar for the year you put in. So this is the calendar command. This is the year. This is 1969. So let's see what's in 2069. So you could like bring up the calendar, whatever you're looking for, without so easily. Okay, so let's move on here. Pretty simple. Date is just nothing but date. Okay, Cal, just you put down calendar here. Okay, so moving along, the next command is who. When you type who, it will tell you who is logged in right now. So right now, root is logged in, Zafar one, um, you have Hamid and Uzair. I don't see Austin and Salman. So that way you could see who's logged in or not, and it will give you the IP address where you're logging in from. And I think it will give you the public IP address. So the system is pretty good at tracking those things. Where? So this is a party session 01, 0, 01, 0, and 2. And TTL is, I think I'm logged in directly as inside the operating system, not through a party or any remote session. I'm directly logged in locally there. All right, who is displays who is logged in? And now I'm gonna clear, now I'm gonna say like last, LAST. And it displays who's been logging in your system. I'm not sure if there is a limit here. I could see somebody logged in like June 19th, somebody named Adil, but it brings up the recent ones up here. Oh, these are pretty old, I think. Uh, yeah, but these are like, these guys are from last year, so I don't know why it's not showing the year. So if you have too much output, what you could do is you could do, okay, I want to see how many people are logged in the last few times. You do last hyphen 30, okay? So it will filter out last 30 transactions who's been logging in the last 30, not last 30 days. But I'm sure you could do that too. If you do man last, I'll show you what a man means in a minute. Host log DNS hyphen L full IP hyphen N limit hyphen P hyphen S displays the state of login since specified time T until yeah, that's what I'm looking for. Maybe it will hyphen hyphen time hyphen format. Let's try that. So if I do last hyphen hyphen time hyphen format. Uh, Host IP limit, how many lines to show? Displays the lines until specified time. Requires argument. All right, so I'm gonna move on here. So you have an idea. Just do last hyphen 20. It will tell you who's been logging in like last. Okay, so it displays who has logged in there. I'm not gonna put that in the text here because it's displaying IP address. So also what it does is it will show you when the system was rebooted. Let's do last. Now you could definitely use that grep command, grep reboot. Okay, so what you could do is this command, if you are troubleshooting a system and you would want to see when was the system rebooted, right? You could definitely see here the system was rebooted on October 11th. And since then it's running. So what you could do is you could do last hyphen 40. And let's see. Okay, let me do 100. So what you could do is you could definitely use this command. So if you get somebody's crying that a system automatically got rebooted for no reason. Okay, so what you could do is you could go in here and then grep for reboot, and you could narrow down activity around that time. What you could do is you could go in here and see on October 11th, system was rebooted around this time. What you could do is you could go and see who was logged in around that time, and maybe those are the people who rebooted here. Remember, Linux system just don't reboot on its own. I've seen a system up for like 1,000 days. That means like 2, 3 years, 3 years, 1,000 days, and the system will still be running fine. Okay, so but it all depends if the system needs any patching or anything like that, then the reboot need to happen. All right, so let me clear this. And let me also put down last 5 grep reboot, and then it will show you like um, if the displays, okay, displays the system reboot time, okay. All right, now let me clear the screen. The next command is free, free-h. What it does is it will show you the memory information here. So if you see something like that, 1.8 GB gigabyte, that means it's actually 2 GB. Unfortunately, what system does is system doesn't give you the exact memory which is installed, but you just have to assume here. If you go into your hard drive and assume like, oh, you have some hard drive like 10 gig hard drive, but in reality 10 gig is not available. Okay, same is with your iPhone or your Android phone, because that's how the system work is. It reserves some memory or the disk space for metadata. Okay, so it's not going to show you the full memory. So in here, if I'm looking at 1.8 gigabytes, in reality, it's around 2 GB here. So you should just assume that, just round it up to next level up. That way, that way you would just look at it here. So total memory is 2 gig, and this is how much is there, and then the buffer cache is 2 gig available. And if you see available is half the memory of your full memory, then you are fine. Okay, if you don't have enough memory available, then it would be a call. It will be a cause of concern, and you have to look into see why that is happening. Okay. Somebody's alarm going. Is that your phone? Whose phone is that? Okay, so free hyphen hedge. Okay, now if you do, the next command is du. Okay, so If I do ls-l and you have this file name messages, right? And if you want to see what is the size of the file, okay? What you have to do is du messages. And it's telling you the size of the messages is 1164. Okay, so I don't know what it means. So what you do is du hyphen h space hyphen h. Hyphen h usually means human readable. Okay, so if you type hyphen h switch, it gives you 1.2 megabytes. So now you are able to read this better. So for example, if you are in a troubleshooting and somebody is crying about that there is not enough disk space, what you could do is you could run this command here. What you could do is you could do du hyphen h, and what you could do is asterisk. So what this is displaying is displaying the disk information that each file is being using here. So if you do asterisk or a wildcard, what means everything, right? It's going to look for file 1, file 2, and the messages. So that way you have a good output.
Excuse me, sir. In the first command, du messages, it's counting the message,
No,
number of
no, no,
message.
no. It is showing you the disk, the size of the message file,
Yeah, I know that one,
but
but the one.
it's showing you in kilobytes.
Oh, kilobytes. Okay, okay, okay.
Okay, then you come here and added the hyphen h means human readable. That means human could understand. Okay, if you have this large number here, oh, I mean, we are not, in reality, we are not familiar with the large number and kilobytes, right? Most of us are familiar with megabytes and gigabytes.
Yep.
Yeah, so if you see this one here, and if you see 4K here, that's pathetic file. It's like cheapest. It's not taking any space. So if you're troubleshooting something and then you have like 100 of these files and one file is this one, or then you concentrate on this file here. And then what you could do is ls-l messages, and you hit enter, and you look who's the owner of the file. You ping them and tell them, hey, take care of this file, Zafar. Your file is sucking up the space. What do you want to do? You want to take care of it and get rid of it, okay? If it doesn't say root, that means that is not your responsibility to manage the file. You have to shoot an email out to that person or whoever that group is. Then that way, you resolve the issue here. If it says root, then check with your team member what to do about it. And if you have been playing around with that file, you could definitely do whatever you want to do, delete it, shrink it, or whatever. So it displays the disk information. It's not the disk information. Du display the usage of the file or folder. Okay, so it displays the usage of a file or a folder. All right, so now the next thing is top. Next command, when you type top, T-O-P. Now here, what you could see is you could see the active information here. about the system here. So what I'm going to do here is I'm going to copy this part here and let me post it here. So later on, we'll have some troubleshooting steps when we are close to the end of the class. What I will do is we'll set up a one session for troubleshooting, how to troubleshoot the operating system here. But for now, it displays the real-time information about system status. And what you're looking for is CPU, memory, and processes. And usually what you do is usually you come here and take a look around these places. This is what you'll be looking at. So here, let me explain you right here under CPU, it's 1.5 gigahertz and 1.2 system. And look at this here, 97.90. Okay, so it's changing because it's going up and down. So up, you could say like if somebody's complaining, the system is locking up and there is no memory, you could come here. Look here. It says 90%, 98%. ID means idle. Okay, so system is not heavily being used. 98% is idle. Okay, so here, right here, let me undo this actually. So you'll be looking at this part. 98, 96% is idle over there. Okay, and then look at the memory here. This is the total memory, about 2 gig. And then it says 162 megabytes is free. But look over here. This is the main part here. How much is being used? It's being used only half of 1 gig. So you have like another 1.5 gig available here. So look here, it says a cache, or you could see here available too. Okay, so if you see available is more than 50%, that means you are good. Oh, I'm sorry. Yeah, this is also the memory information. This is the swap memory. Swap memory, I will explain you in greater detail a bit later in the course. But swap memory is nothing but the memory is we have only 2 gig here, right? Another 2 gig is the disk space. So you have to distinguish between a memory and a disk. Disk is a storage and memory is a volatile memory. Okay, it is a memory only being used when the system is powered on. If the system is powered off, this is no good. Any information in the memory is gone, but any information in the disk, it stays on. But here it says swap memory. That means still it will lose information if it has anything in swap because it's used as a memory, not a disk. So here you look at it here, more than 50% is on, it's fine. And then look at this here, you're fine too. Okay, and then I'll talk about in greater detail what these PID and all those stuff is, okay, later in the course. So next command is lscpu. LSCPU means list CPUs. How many CPUs are installed on this system right now? So look for core socket, and that way you could declare that this system has two CPU in it. This is other information here is usually I'm not worried about it, like what this is. I'm not worried about it. Usually what I do is I do ls CPU and then I want to see how many CPUs are installed here. Oh, sorry, actually it's this one here. It's a CPU. It's two CPUs and it is it could be used like 32-bit or 64-bit. So you have that information here. So let me copy this and put it in here. Displays the number of CPU system has. All right, now the next command is which. If you type which, and if you type tree, and if you get an output like this, that means the program tree is installed on the system here. And if I do which Tomcat, okay, whatever you're looking for Tomcat is not installed on this system. Okay, so before you install something on your system, you could check that, or you could do which Firefox, and Firefox is installed on this system. So for that, you have to go into the GUI mode. So I'm not worried about this at this moment here, okay? So let's see here.
But Tomcat is a server, right?
Yeah, there is something you could install on it. But right now, it's not installed. So that's what we are using, which command is to see if it's installed or not. That's just a quick and easy way to see before you start doing anything on the system. If the command or package is installed. Okay. All right, moving along. So all of a sudden you have this file here, right? If I do ls-l, so let me do du messages, right? So if I do du-h messages, so let me do one thing here. Cat messages, messages one. Okay, what I'm doing is I'm making this messages one a big file. So if I do du-h messages one. Okay, so it's 16 megabytes. Let me do it like few more times. What I'm doing is I'm adding like bunch of lines in here. Okay, so du-h messages. Okay, so all of a sudden I have this messages file, a huge file here. So let me play around a bit here. I want to bring it to like 1 gig or so. Okay, so 512. So I have this messages file about 1 gig, right? And all of a sudden, it's not desirable that we have a 1 gig file and it's sucking up the disk space. Okay, disk is limited. Okay, and if the disk is too much, what will happen is it will affect the system performance. So what I'm gonna do is I'm gonna do a command, built-in command, gzip, and then I'm gonna do messages and hit enter. It takes few minutes and it comes back depending on the size of the disk. I'm sorry, depending on the size of the uh, file, it takes a little bit. If it's 1 gig, it's still working on it. So what it's gonna do is it's gonna compress it.
That
G
one is not working. Right.
You have messages in there?
There's no such file or directory exists.
Yeah, so use the copy that from home, cp space /home/messages and do the tab key to autofill it. And then space period.
Tab doesn't work.
It's not there? Are you typing /home?
Yeah. That-
Okay, then give it a space, then type a period. And hit enter. And it should copy in your home directory.
Yeah.
It's there now?
Should be.
Do ls there and you will see the file in there.
Yes.
Very good. So gzip, and if you do ls ls-l. So what it does is once you gzip it, it adds the extension .gz. That way you could tell the system has been zipped. That means it has been compressed. And if I do this here, okay, now originally the disk space was 1 gig. And then now it's down to 44 megabytes. So it shrunk from 1 gig to 44 megabytes. That means it shrunk it 20 times. So just think of this as 50 megabytes and this is 1 gig. So it shrunk itself, 20 times. So saving the disk space 20 times. So 20,000 times, is it what? 200,000. So it's saving 2,000 times the disk space, okay? All right, so you did gzip, and all of a sudden you need to unzip this. By the way, you will come across the scenario somebody needs this file. So what you could do is you could send this file or put it in the /temporary file. We'll talk about permissions in /temporary file later in the course, how you move around the files and stuff and the permissions. And you do gun zip and then messages. And it's going to take a bit here, and this is going to bring it back to its original size. So gzip is zips and compresses the file. It adds the extension with .gz, okay? With .gz, it adds the extension, okay? All right, so I'm gonna put it here, the command. And then to unzip it, gunzip, gunzip. What it does, it unzips and uncompresses. The file, okay? So now if I do du messages, it removes that .gz, and then oh shoot, I used the wrong command here. du-h messages, okay? And now it's back to this. Okay, so I'm not sure why it's saying 800 megabytes here. Usually it should have been showing me messages. It should have been showing me 1 gig here. Earlier it showed me 1 gig, but I think in reality this is what it's the correct information is. Okay, so there is a little discrepancy, but we could move on. All right, so what if you want to um zip a folder? So in that case, tar command comes in, tar. Okay, but before that, let's make a folder here, ls-l. What I'm gonna do is mkdir. I'm gonna give it a name folder1, okay? And hit enter. And then if I do ls-l, you have all these things here, right? What I'm gonna do is I'm gonna move all these files here into folder 1. Okay. The reason I got this message is you cannot move the folder inside its one. So when you add this asterisk, it's trying to move the folder itself in folder 1, but it has not done that, and that is fine. If I do LSF and L, file 1, file 2, and messages are sitting inside folder 1 now. How do I know? If I do LSF and L folder 1, you will see all the files which are inside this folder, okay? If you don't do without folder 1, this information is coming on the present working directory. But if you're specifying a folder, that means it's grabbing the information from that directory, the directory you specified. Okay, so I have this here. Okay, let me put this part here. Okay, so this is informational. Okay, but let me clear the screen. So the real command we are after is tar, T-A-R. Yeah, so what it does is once you tar, before that, let's do here du-h folder 1. In this scenario, you could check the size of the folder also. Okay, so the size of the folder is 800 and yeah, go ahead and make one. mkdir folder 1. Then run the move command, move asterisk folder 1. Yeah, I mean, if it comes up slash, it's fine too. Just hit enter. It's fine. Because I explained in a bit earlier that it's trying to move that folder itself. But if you do ls-l folder 1, you should see output in there, right? How many files you got? In output ls-l, how many files you have? It's fine. It's fine. Yeah, that's fine. You have a bunch of files here. So what we could do is, so tar command, what we're gonna do is we're gonna make it as we're gonna create copy that folder and make it as a single file. Why? Because you have to tar it. It's called tar ball actually. You could like put all the files uh, in one folder. That way, you could manage it better and then you could zip it better. Okay, so the command is tar hyphen cvf. Okay, and then you type folder one dot tar. You have to specify this time, and then the source. So in this scenario here, what is happening is this is the command, and so this is the command, this is the switch, and this is the destination. Okay, and this is the source. So destination in this scenario, this is okay. Give me one moment here. I got disconnected. So in this scenario, destination, that means if it doesn't exist, it will create it here. And this is the source. When we are moving and copy, we have to provide the source first and the destination later here, right? But it's different here. You provide what you want to create first, destination, and then what is the source. Okay, so it's a bit odd, but I hope you understand that. Okay, so give me just a moment here. I have to get rid of that. So let me. Share it again. All right, you see this? You see this here? Okay, good. So, so you do this command here and you hit enter. What it does is, it is it takes a bit to put all these files inside the tar folder here. Now, if you do ls-l, now you have the original folder. It keeps the original folder as is, and then it made this original folder as a file. Okay, so this is the original folder. Oh, you caught up? Okay, good. And then this is the folder one.tar. This is like a file now.
Should be a zip file, right?
Not yet. If you look at the size is pretty good still, pretty big. So now what we're gonna do is now we're gonna zip it. If you do du-h folder.tar, and it says it doesn't compresses it. But right now, folder one is as if it's a single file. What are you gonna do? Now you're gonna do gzip folder one.tar and hit enter, and it creates it as a single file. This is a bit challenging, but if you do it like few times, you should be able to do it, and you will grasp what I'm saying here. It saves the folder or directory to single file. It does not compresses it. It does not compress the tar file. It keeps the original folder and creates new as file. All right, so I'm gonna give like a 2-minute pause and see if you guys have any questions here. Okay, so now let me have a 2-minute pause.
So, sir, it means it's not just like if you compare with Windows, when you use WinZip, it zips the whole folder as a file, right? And its extensions change. Over here, change the folder as a file, but don't it doesn't zip it. For zip, you need to have a gun zip, right? Gzip.
Yeah, gzip. Later on, what you could do is you could combine both gzip and tar commands together, and then you could do it. So
Oh,
I'll show that in a moment here.
okay, okay.
So I mean, I'm splitting this up so that you understand how this is working.
Yep, yep,
You
yep.
could do that too.
Yep.
Anyone has questions? Okay, so moving along, what I'm going to do is where am I at? Okay, so Now, if I do ls-l, now if you see here, the folder is now um, the folder is now has been uh, has the .tar and .gz command also on it. I'm sorry, not gz, tar as well as .gz extension to it. So it kind of bit odd here, but sometimes it's good to know that when you have tar in it, that means this is a folder. Okay, so if you have a tar in it, that means it's a folder. So right now, what I'm gonna do is I'm gonna copy this part here. Now let's see, du-h folder. du-h folder.tar. Okay, so now you see here the size of this folder is now 44 megabytes. Earlier it was huge, right? The size was yeah. Now it's like for you it may be even smaller. It's in kilobytes now for you. Okay, that means it's working. So actually, let me copy all this here. Okay, so let me dissect this part here. So here, what you're doing is a hyphen CVF. Okay, I need to explain what CVS is. Man tar. Okay, C is tar hyphen C means it's telling you to archive. V means verbose, means it's asking you, showing you verbose means in Linux, verbose means it displays what is happening here. If you don't have verbose here, it's not showing it's this folder one, folder two, and messages. It's not going to display that. It's going to just go blank and then come back. And then F here, why man? So guys, I am not in daily use. I'm not going like directly in there. C is why is it not explaining me what C is here? Give me just a moment. Okay, C means create, V means verbose, and let's see what F means here. All right, give me. Okay, so I'm gonna put down hyphen CVF. Okay, what it means is C equals create, V means verbose, and F means you're specifying this as a folder. Okay, so that's what CVF means. All right, so let's get going here. Okay, in this part, we are doing gzip here. And this part has been done. And this is a garbage output. Okay, so is this one here. And okay, so the folder has been squeezed in here. And this is the result of the gzip folder. And this is the result of a tar. Okay, so it's not very complicated. First, you have to tar it, then gzip it. That's it. Okay, tar, gzip, and you have the folder as a compressed single file. And why do we use this here? Okay, this makes copying or moving folder easy. This keeps the data. Oh, actually, yeah, tar is used for the data integrity of the content, especially copied over network. So if you're moving files and so there is something called metadata, right? And the permissions and stuff. It is possible that if you copy from one system to another system, it may be lost. Okay, we may run into this issue during permissions. Okay, if we run into those things in permissions, I will show you how that works. And then here you can use gzip and gunzip to compress and uncompress the folder. Okay. Okay, now what you have here is, let me clear the screen. If I do ls-l, now usually what happens is you have to okay, so what I'm going to do is I'm going to do gunzip folder one dot tar dot gzip. Okay, if I hit enter, it's going to go away, and then it's going to come back here. And if I do ls-l, so I have this folder dot tar back here. But if you see the size of it, it's back to its original size here. Okay, you don't want that. Now we are running into one problem here. If we tar it here, the original folder is still there. Okay, the original folder is still there. So you cannot have same thing named with the same name and content in the same place. Okay, what you have to do is you have to untar it in a different location. I'm going to do mkdir dir directory 1. Now I'm going to move folder dot tar into directory 1. Okay, now I go into directory 1 and then I'm going to run this command here. If I do ls-l, now the command is tar, tar hyphen xvf. Okay, so X stands for extract verbose folder. Everything else is the same thing. And I'm going to say folder 1. Folder 1 dot tar. So it's going to do this. And essentially, what will happen is for us, it's going to remove that dot tar and give it only the folder 1. Okay, so but in reality, it changed it back from a file to the folder. If you do ls-l, now you see the folder 1 is there. Okay, wait a minute here. Where am I? So now you are surprised here. You see tar is still there, but folder 1 got generated here. So what happened is it will still keep the original tar folder there and unfolders it. So in Windows, when you unzip it, it still keeps the original zip file, right? And it throws the whatever it's unzipping into the directory of your choosing. By default, it does that. So this same thing happened here. If I do ls-l folder 1, and you see the content of this folder in a different location. Okay, it's a bit complicated for a simple command, but it is very, very simple. Okay, why? Because you have to understand two different commands working together here. So let's see here, what should I copy? Okay, this part here. Okay, so I'm gonna make a note here. Tar should be untar in a different location than the file originates. Okay, and this part here. So I'm gonna split this up. You made a directory and you went into the directory and all this, and this part here. I'm gonna move it down here. And this part here. Okay, so you extracted here and you came back, and this is the directory, you would put that in there. And this is the folder no, this is the folder it brought back after uncompressing it, right? So after untarring. Okay, so let me clear this. Let me go back to my home directory. And let me get rid of directory 1. I'm gonna remove that. Yeah, there it is. But what I want to do is I want to tar it and zip it in one shot. Okay, very easy. What you have to do is tar hyphen CZF. In here, what you're doing is create Z means compress the archive file with gzip. And so what I'm going to do is, before that, let me do ls-l. Yeah, should have only folder 1. Tar hyphen create gzip using Z means gzip using zip it using a gzip file, and then fczf. Okay, and now I'm going to give folder 1 dot tar. Okay, originally when you do this, you still have to provide dot tar, right? Earlier when we did the tar cvf, we provided the name here dot tar. It is not automatically gonna do it. If you think you could do this and make a change, you could do that and submit to the GNU, which is an open source authority. And this has been a pain, and you made some changes, so you will become a popular person in a Linux community. Or you made a change here and you improved on it. If it's something you could improve on it, you could definitely change it around and submit it. And if they agree, then it will be integrated as into a next upgrade. But so far, nobody else has done this, so we have to live with it. And I'm going to see the source now, folder 1. Now, don't forget that GZ. You have to still provide that GZ also manually. Okay, now hit enter. It's doing this. We could have add V also in there, but I didn't add V in here. So it's not going to show you. V is what? It is showing you what the activity happening with that command, verbose. Yeah, because your file is pretty small, I think. The messages file. I redirected the messages file into messages one like many times and make it go fatter. Okay, now if I do ls-l, now all of a sudden I have dot tar and dot gzip. So I saved one step. I saved one step here. So if you are just trying it out, you could do that. So okay, so now what's gonna happen here is you have this folder and then you follow the previous command. I think you could use the single command also, but before that, let me copy this part here. Tar and zip using single command, okay? You remove that and you copy this part here. And there you go. This is your final product, okay? And this is the command you're running, czf. C is equal to create, Z equal to using gzip command, and then F equals to folder. Okay, guys, I keep telling you, wherever it's uppercase, assume it's always lowercase, okay? Unless notified. Now, what you might want to do is you could do, now we all know we cannot keep this folder in the same place, right? So what you could do is tar hyphen X. Now we are going backwards. X means extract using gzip at the same time and a folder and folder one dot tar. This time around, I'm gonna give hyphen C and then give a directory name. Okay, it will create the directory and then it will put that in there. Or you could provide the path of that directory. That could be now if I say path, how many kinds of path we have? Yeah, you got it. So here you could provide the absolute or the relative path. And I hit enter. What is the problem? You may not specify more than one and delete or test label option. You know what? Capital C maybe, okay? Cannot open, okay, oh. I thought the directory was already there, but you have to manually create a directory. mkdir directory one. Okay, and then you run this command. Okay, so it's going in there. If you do ls-l directory. All right, guys, I think people online are a bit muted, but don't get discouraged, okay? We have Austin here. He is very good with Linux and he's a coach for this class. Please put any questions you have in the group and he will help you. All right, so it's a bit overwhelming today, but next week we won't have a class. We will have a break and you will have like a good 2 weeks to practice this, okay? But please use the group chat for any questions, anything, and then practice it no more than half hour. Okay, just half hour, you come to the computer and practice it and come back. And now, actually, let's take a break here. We'll take a break. I've forgotten about this. I should have taken a break half hour ago. We take a break and then actually we'll wrap it up early today because we are towards the end of the um, towards the end of the basic command here. From next week, next session, we'll get into a real stuff. This is also real stuff, but let's stop it here and get into the break here, okay? We'll come back at 9:50 Central, 9:55 Central in 20 minutes. All right, break starts now. Okay, so we did untarring and all that, right? So let's see what we have. Okay, so we have three more small topics and then we'll wrap it up for today. And then next week, there's no class. And then, please try to complete the assignment. If you have any questions, put it in the chat, okay? So the next topic, mini topic is stat, okay? So what stat does is it displays the detailed file information. Okay, so let me see, let me clear the screen. ls -l. Let me go into CD folder. Let me move all these things back to my original directory here. Okay, move asterisk. What if I do this here? What is this doing? Two dots. Two dots. What does it do?
Back to root.
No, not back to root. Back to previous working directory. Okay. If you go here, what about the single dot? What does the single dot means?
For the previous directory. Single dot was the previous directory.
No. Single dot is present working directory. Directory you are in. Yeah, you're going, okay, so here, single dot, double dot. Single dot means, this means present working directory. Two dots, this means parent working directory. Parent working directory is also means previous. Okay, so if I do PWD, in this case, right now I am in folder 1, which is here. And then I'm moving MV asterisk two dots. Two dots means the parent of folder 1 is Zafar 1.
Sir, typo MV.
Yeah. So if I hit enter, and if I do LL, I shouldn't have anything here. And if I go back to my home directory, and if I do LL, there you go. You see, LSFNL, you see my original files that came back here. These are the extra folders we created. So what I'm going to do is, so we are done with this here. Let me try get rid of this here, okay? RM-RF. And then this time around, I'm going to do folder asterisk and I'm going to do directory. So I should be only left with messages here. Okay, so let me clear this message. And what I'm going to do is I'm going to do stat messages and I'll hit enter. All of a sudden, The regular ls-l messages, oh, let me clear this. ls-l messages is giving you one line information here. Stat messages, it has like a lot of information here. Okay, so why is that? So okay, so what we are seeing here is we are seeing the inode information, the stat information that displays this information here. We ran stat messages, but it's displaying the inode information here. Inode, okay. So what we have is we have name of the file is messages, and we have the size of the file is which is 800 megabytes. Okay, and then what we have is block. Block means this is the location address of the file sitting on the disk. Okay, and IO block is the size of the smallest block. So you divide each block is okay. You have a bunch of blocks, right? On a hard drive, you have bunch of blocks. So what you have is so I have a picture of a container here, right? Each container, think each container is 4096. 4096K. This is 4096 bytes. That means 4 kilobytes. All three these things are interrelated. I'll explain you what each block means. Okay, and size, and we have a device information. That means it also means where is it located. Oh no, I'm sorry. Block is how many blocks it's using, and then this means the location that is sitting on the disk. Okay, and inode is the file number. So there is a file name and a number is also there. And link means there is one link to itself. Okay, did I teach you soft link and hard link? No, right? Okay, yeah. I think we'll do that next week. Let me sit down. And then this part is permissions. Who is able to read and write will go in a greater depth. And then this is UID, user information. Who is the user who created this file and the ID of that user? Group ID is whoever that user is, what is the group of that user, organization of that user who created this. In this case, is same. And then this is context means SE Linux. This is a security part. We're gonna learn that also. And we have the file activity. So when was it last accessed? So today it was accessed at at this timestamp. This is 10 a.m., 2 minutes, 5 seconds, and these are milliseconds. This is really important because Linux operating system is also tracking down to milliseconds. So this is the billionth of how many zeros are 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's tracking down to the billionth of a second. Okay, same thing. When was it last modified? It was modified today at 9:47 p.m. an exact a billionth of a second it's tracking. When was it actually changed? It says 10:58. Okay, 24, 12, okay, today at 10:58, it's doing this here. So why is it showing 10:58? Oh, okay. Yeah, 10:58 p.m. We moved it from other directory to this directory here. And then the birth. Birth means when was it actually created? This was created around this time here. Okay, so I'm going to put down in here inode. So it is a table on the disk holding the file information. Okay, and it says owner of the file, group of the file, owner of the file, group of the file, type of file, permission, date and time of the file, modified and access, and the number of links. Okay, and the size of the file and block information. Okay, so this is the uh, this is what is displayed here in a stack. The information you're seeing is called inode. Okay, inode information. That means the name inode is all these things for associated with the file and also the folder. Don't forget file and folder. These are both mean same thing. Okay, and then block information. So the things are the building block is if you heard about byte and bit. Okay, bit and byte are very important here. So let me do, let me just, yeah. So I have this picture here from internet. So what this is displaying is the information here, bits and bytes. Okay, so in reality, this is how it is. So everything starts with bit. One bit is 1 bit. It says 1 bit, right? And 8 bit, 8 bit is byte, B-Y-T-E. Okay, equals 1 byte. And then kilobyte equals 1000. Kilo means 1000, right? In reality, it's actually 1024 equals 1 kilobyte. And then 4096 is 4 kilobyte. So let's take a look here. 1 bit. Okay, so 8 bits, right? Um, 1000 times 8. 8000. No, actually, okay, 2 to the power of 2 to the power 2 times 2. 2 times 2 is 4. Okay, 1 byte is 2 to the power of 3. 2 to the power of, all right. So if you're weak in math, and math will haunt you guys, I'm telling you, it will come back and haunt you if you're not good at math here. So 1 bit is 0 and byte is 8, right? So this is 2 to the, where is the power of? I don't see the power of. Do I have to change it scientific? Okay. All right, let me clear this. And 2 to the, where is power? Okay, 2 to the 4. Okay, 2 to the power of 3. Okay, so let me cancel this. Okay, this is bad. So this one is 2 to the 2 multiplied by, I'm not sure, is it 0 multiplied or 1 here? This is 1 multiplied by 1, okay? And then this is 8 is 2 to the power of 3, I think. Let's go back here. 2 times 2 times 2 is equal to 8. Okay, so this is 2 to the power of 3, and kilo is 2 to the power of times 2, 6 times 2 times 2 times 2 times 2 times 2 times 2. Okay, see, 1024. Okay, so it's not 1000. So how many times it went there? 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let's okay, Google 2 to the power of 10. Okay, so I have a Google calculator here. I did 2 to the power of 10. It is becoming 1024. So here 1024 is 2 to the power of 10. And then this is a, by default disk size. So here it says 1026, 4096. If you have a file So imagine the tiles of a floor, right? If you're putting something on a floor and you're looking at the tiles, and if you're putting that object on the floor and it's using up the space, one tile, right? And one tile is 1024. So that file will be considered using up the space 4096, even though that object is smaller than the file itself. So if a file is like 5 kilobytes, okay, so if we do ls earlier, okay, we'll do touch file one, and if we do ls-l, that file is it's barely anything here. Okay, so but if you do stat file one, okay, so look at the size here. Even though size of the file is barely anything, it is still using 1024. So it's using up that space there. Okay, so what happens here is, based on that, it will start using up the disk space. So if I have this table here, 4096 equals 4 kilobyte minimum usable space, disk space. So if I have like a file size, disk space. So if I have like a file size 0, still using 4 kilobytes, right? But if I have 1 kilobyte, still using 4 kilobyte. What if I'm using 2 kilobytes? What if I'm using the file size 2 kilobytes? How much is using? No, still using 4 kilobytes, because 2 kilobytes is still smaller than 4 kilobyte minimum size, right? Now, what about if I'm using 5 kilobytes? How much is going to use? 8 kilobytes. Unless that space is filled up, is now going to go to another one. So what if it's using 21 kilobytes? It will be using 24 kilobytes. Okay, so all these things matter, and it adds up how the disk is being used. So you have to be just cognizant about this and understand how the disk is using, and the less the disk is used, it all translates into the money, right? If you don't have to add an extra disk, that means you're saving money. So you have to be a bit frugal about this here. It sounds like, oh, you are dying for, why you want to save a little bit on the disk space, but we are dealing with a data which is ever expanding. So it is huge data, and the size and the disk space. Okay, back in 90s, the size of the one picture used to be like a whopping 1 megabyte. Oh, 1 megabyte file. And the floppy disk used to hold like what, 10 pictures now. Now you need like a 10 MB camera, so you need 10 floppy disks to just hold one picture. So you understand now that how this thing is ever expanding. Okay, now let me quickly show you some the link information here, right? So let me go back here. Okay. So next information here is links. How much time we have? Yeah, I'm gonna wrap it up in the next 10 minutes. Okay, so if I do stat file one, it is showing a link here. What do you mean it has a link? The reason a file has a link is every file is linked to itself. Okay. You are a link to your soul, right? But you don't see the soul here. That means you are a link to your own. That's how it is. So link two types of links for a file: hard link and soft link. Okay. Okay, so let's talk about a hard link. Okay, so what I'm gonna do is I'm gonna clear, I'm gonna do ls-l. What I'm gonna do is mkdir-p Chicago, and then I'm gonna say Iowa. And if I do tree, okay, Chicago and Iowa is there, right? What I'm gonna do is let me just put the definitions here. Okay, so first is it has same inode. It has the same inode number. Okay, and you have to provide source and destination. So when you're creating a link, you have to provide source and destination. Okay, and any change to either file will be updated on both sides. Okay, essentially hard link is duplicate of each other. And you can use this as backup. And if the original file is deleted, the hard link still survives. So it's a copy. I'm not sure in Windows if you have like a file in two different places. If you update one file, if it's gonna update the other file, I'm not sure about that. But here, this is, you could use it as a backup. Hard link is not possible on folders. So let's take a look here how we do it here. Very first thing I'm gonna do is create the link here. Okay. So what I'm gonna do is I'm gonna do LN, that stands for link. And then I'm gonna say file one, And then I'm gonna say, what is it, Chicago, Iowa. And I'm gonna give it a name file 1 or file 2. Okay, and if I do tree, so I have a file name here and a file name here too. So very first thing, link has the same inode. Did I talk about inode earlier, right? So how to check inode? You do ls hyphen I as in India, and you do file 1. Okay, so inode is 9316416. And then let's check the inode for file Chicago, Iowa, file 2. Okay, if you're paying attention here, look at the inode number here for file 1 and inode number for file 2. They are exactly the same. Okay, so okay, so look at the inode number here, and I'm going to give it a space here and here. So you have to provide source and destination while creating. Okay, you could give the different name though. Okay, so ln is the command. Provide source and destination. And name destination name can be different. All right, this comes handy later on. If you want to have a file being read by application with a different name, but the source file is something else, that will work too. Let me do cat file 1. There is nothing in there. What I'm going to do is echo, and then I'm going to say this is a hard link file for file 1. And then I'm going to send it to file 1 itself. Okay? And I cat file 1, and there you go. The line is in there. What do I expect when I cat file 2? Cat Chicago, Iowa, file 2. I'm going to expect the same exact thing in there, even though I didn't put anything in there. Okay? There you go. This is the hard link file for file 1. What I'm going to do is I'm going to bring the echo back to file 2, and yes, this is a hard link, and then this is file 2. So I'm sending this to file 2, but if I cat file 1, that information is updated on file 1 too. Oh, shoot. Can somebody tell me what I did wrong? What I did wrong was 2 things. One is it should be double, and then should be the full path.
Absolutely.
If I do LL here, what will happen here? I could see file 2 also, because file 2 was generated here. So this is a classic example. You have to see what you're typing. But you roll up the line up here and then you do double. And you do Chicago, Iowa, and file 2. Okay. Before that, let me copy this part here. And then now I'm going to do cat file 1. Okay, see now I have the original line and then this line here. Okay, so makes sense here. This is a hard link, and it's the hard link means essentially it's a same file, but it could be a different name. It's updating itself. So update means if you want to delete a line or you want to zero out the lines, it all means updates. Okay. So what I'm going to do is tree, and then I'm going to delete file 1, the original file, rm-rf and file 1. And if I do tree, file 2 still exists, okay? If either of the file is deleted, other file still survives. Okay, so I deleted this file, but file 2 is still there. Right, file 1 is here and file 2 is here. So I remove one file here, voila. Other file is still there. So let me just give it some space here. Okay, and then we are down to soft link, okay? Soft link. So what is soft link? This is also called a symbolic link. Symbolic link or symlink. A lot of Linux people, they say, what's the symlink? Okay, symbolic link or symlink. You have to provide absolute path when you're creating a file. You have to provide absolute path for the source and destination. Soft link has different inodes number. Most of the time, soft link is used for reading data or restricting access. Editing a soft link actually updates the original file. And if the, oops, what are I doing here? If the original link is broken, soft link is useless. Okay, and soft link is allowed for directories. Okay, so I'm gonna clear this and I'm gonna do rm-rf. I'm gonna delete everything here. I'm gonna start from scratch. Touch, 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 file. No, I'm gonna give a unique name here. I'm gonna say touch X file. Okay, one. So now I'm gonna do mkdir uh, -p, and then I'm gonna do Chicago. I did Chicago and Iowa, right, earlier? Yeah. So I have this file X file here, right? I'm gonna make a link here. So pwd, I'm gonna make ln-s. So the source and destination, I have to give the uh, absolute path. So this is source X file, and then I'm gonna have to give the absolute path for oh shoot. I'm gonna have to give ln-s. Okay, earlier we did ln, we didn't give any switch. If we're giving switch, that means we are telling this is a -s switch, means that this is a soft link. And then I'm gonna give home Zafar 1, Chicago, Iowa, and then I'm gonna give it a X file name. I'm gonna give it a Z file, Z file 1. Okay, I didn't get any error. That means it worked. Okay, ln-s is the switch you use for um, creating the -s will create a soft link. So here, so here is ln hyphen L is a command, and you have to provide the absolute path for source and absolute path for destination. And once you have done that, it will create the file in here. And notice we gave the soft link as Z file, right? But it is telling you the location of the file here. So SoftLink has this capability that it shows you the little location of the location of the soft link which it is connected to. Okay, now let me take a screen grab. And let me put it here. Come on. Okay. Okay, I'm gonna give 2-minute pause. Anybody running into issues, having any problems? And if you do inode ls hyphen I as in India, and it will give you file, and then ls hyphen I Chicago, Iowa Z file, and you notice the inodes are totally different. Okay, this is the reason you have soft link here. Okay, I'm gonna clear this. And what if I like if I do ls hyphen L, or let me do echo, this is soft link, and then I'm gonna put that into Chicago, Iowa Z file. Okay, and then I'm gonna say cat x file. There you go. The update is done. Okay, so now what if I remove the file here? Okay, rm hyphen rfx file. Okay, the file is gone, but if I do tree, you see here it's highlighted in pink. That means the file has been deleted. But if I do cat Chicago, Iowa Z file, it says there is no such file or directory here. The file itself is there, but what it's actually reading, it's actually reading this file here. But it wasn't the case here in hard link. We deleted the original hard link, and then the the link that was originally was deleted, but the link itself is survived and it has the content in it, okay? So I'm gonna pause here. There is one more command, find command there. I think we should stop here. I will pick that up next week. It's a smaller command. And we'll just use that next week, and then we'll deep dive into other areas into Linux here, especially doing the directory structure, and those things will come into play. All right, guys, so I'm gonna stop here. I'm gonna upload this as soon as I can. And if there is gonna be assignment, I'll upload it. But there is no on the assignments, there is no time frame when you could submit it. Just submit it whenever you are able to, but try to complete it, okay? Because this is for your own benefit.
Okay. All right.
All right, so Austin is there. Please use him and he will help you out